Okay, so we're going to talk about circuits. Okay, so we've talked about this before, but electric current is essentially just a measurement of electricity. A circuit is a closed path through which electrons can flow. Okay, so if you look down here, you'll see the diagram of electrons going this way from the light bulb. And this little symbol of E with a negative sign after it, that stands for electrons. So they're flowing into the positive end of the battery. Okay, because remember, negatives are attracted to positives. Okay, and they're going to get pushed out of the negative end of a battery because you remember that two like charges repel. So electrons are going to push away from the negatively charged end and are going to travel through the light bulb. As long as this path is a closed path, in other words, there's no openings in it, nothing is, and everything's connected, this should turn on. Okay. Electricity is mechanical energy because it is moving electrons. That's one version. There are other versions that just say electricity is its own type of energy. Depends on what book that you look at. Okay, so circuits. Circuits have different parts. The main important part is you have to have a voltage source. So you have to have a source of electricity. This provides the potential mechanical energy that could power the circuit. If you're going to have a flashlight, it has to have batteries that work. If you're going to flip on a light switch in your house, you have to have a source of electricity from somewhere. Okay? So we had parts of a circuit where the voltage source, and then you have the conductor, which is the material that's going to allow the electricity to flow through them. Usually in a circuit, these things are wires. Sometimes it could be metal plates, different types of plastics that are actually conductors, things like that. So for our circuit, we had our voltage source, we have our conductor, and then we have our receiver. Notice the light bulb in the background. A receiver is the thing that is actually going to receive the electricity and do something with it. It's going to convert it into a different type of electricity or something like that. So it's going to, so different examples that we have on here, we have light bulbs, hair dryers, cell phone, video games, the actual console. So like when you push the button to turn on your PlayStation, it's the PlayStation itself is taking that electricity and going to do something with it. Same thing with your TV. Okay, so then we have the switch. The switch is the part that opens or closes the circuit, turning it on or off. So you have light switches, power buttons, on, off buttons, anything like that is actually going to cause the circuit to close or to have a break in it and technically call it open. Okay, so these pictures you see right here, the top one, you see how this little flap is angled open? That is an open circuit. This doorway looking thing here represents a switch. When the switch is open, electricity does not flow through. So this would be like if you had if you had like the lamp with the little push button that you push to turn the light on. If the light is off and the switch is one way, you flip the switch and turn it the other way and the light turns on. In your house, on the walls, the light switches. If the switch is one way and the light's off, you flip it the other way to complete the circuit and the electrons are going to flow through. Okay, so resistance is kind of exactly what it sounds like. Resistance is how much something resists something else. So resistance for electricity is how easy or difficult it is for the electrons to pass through a circuit. There are certain substances like copper that are very easy for electrons to travel through. Hence the reason most of our wiring is made out of copper. Some other things like wood, it's much more difficult for the electrons to pass through. Also, the longer the wire is, the more resistance there is. That's why that video we watched about Thomas Edison and Tesla and the AC/DC current, and if you remember, they talked about with the DC current, he had to have repeater stations every like 2 miles or something like that to keep the current flowing down the line because the lines were so long. Okay, schematics are kind of like blueprints for electricians. Electrical engineers will do this, and they will actually build a circuit building schematics using symbols to represent different parts. So you'll see here the different symbols that they use. For batteries, it's usually a DC voltage source. And that's because it's a direct source of power. Another reason why your batteries don't last as long as this one. So your wall outlet is an AC voltage source. Remember we talked about that the entire electrical grid now is alternating current. Resistors have this kind of squiggly up and down look. And they do put those in certain places on purpose to kind of slow things down a little bit. Your wire is a straight line. Your switch kind of has a door look to it. Here's what you have for a lamp, and here would be a motor. Okay, alright, so there we go for electricity and circuits.